There's no sense in which we're trying to replace algebra. Algebra is this beautiful system that took hundreds of years to develop, and we want to open access to that beautiful set of ideas.
The concept at the heart of mathematics is very difficult to learn and teach. The MiGen project is unlocking the mystery of generalization to unlock the wonders of maths for 11 to 14-year-olds with an intelligent microworld that presents algebra in a new visual format. So what are the types of issues that can confuse students?
Here's a really good example, the idea of a variable. I say to the child, x can be any number, and the child thinks to itself, okay, 7. But that's not what any number means. What looks like a really simple idea if you've already got it is actually a very complex idea with many different layers of understanding that are necessary.
You think, well, this is so easy, so obvious, and you actually standing there, you see how terribly difficult concepts are. You can gloss over that and say to them, oh, this is what you do. Do you understand? And you'll get 30 nods. And you carry on presuming that they have understood, whereas in fact they haven't.
This has been a big problem in teaching maths forever, and lots of people have tried to exploit resources to help teachers teach students about algebra in all different ways. And what we were trying to do is marshal all the evidence from computer science and from education and from mathematics and say, can we actually devise something that would really make a difference using all the possible up-to-date techniques in computer science and all the knowledge from education.
Expresar is what the child sees as they're interacting with the system. It's a micro world, which is an idea that's informed many developments in technology-enhanced learning. The idea that you constrain what it is that children can do on the screen, but you constrain it in careful ways so that they bump into powerful ideas.
What the computer can do very concretely is, first of all, you build a particular pattern. Secondly, the computer in our microworld, which is really neat, really cool, will say once you've made the numbers variable, the computer will generate a different value for the variable in a little window. So you can sort of keep an eye on the general, even though you're working in the particular. And this is something that is absolutely what mathematicians do all the time.
And the model can choose any number to demonstrate for their pattern, whereas you can't really do that on a piece of paper. Whereas with the system, immediately you can see all values for your variable and get a feeling of what happens to your model, to your construction.
It is better than just sitting down with a textbook. You can actually see what's happening, so you don't have to visualise it all in your head like you would if you're reading it from a textbook.
You can have like different building blocks to do different things. So you could have a whole one, you could have like different building block each time, in different ways to do it. It's a lot easier.
The intelligent software developed by the MiGen project is designed to help students use Expresar, but the team considered the ability to offer teachers support and information as equally critical.
While the students are undertaking this construction through the graphical environment, the system tries to also provide them with hints and nudges and prompts to help them towards a productive construction of the model. So it's not trying to instruct the students, do this and then do this and then do that, but it's trying to encourage students to explore the nature of the relationships in these graphical models and to uncover rules for themselves.
So you've got Bob is 1, and yet you just told me that you wanted 5 of them coloured. So how are you going to change it?
We want to recognize the role of the teacher in the classroom, but we wanted to create a good kind of relationship between the teacher, the system and the student. It's really useful to be able to delegate what is easy to tackle with the system and let the difficult and important aspects for the teacher.
All we know is if the teacher does everything, the child learns next to nothing. The child has to take ownership. So what you hope is that the computer will act as this mediating layer to introduce the new ideas, to give feedback, say, hey you, this is the computer, saying, think about it. What do you predict will happen?
Because we think that the teacher has a crucial role in helping children understand these kinds of ideas, we've built a set of tools which support the teacher in what they're trying to do. give teachers an insight into what their students are doing and to support them in what they do best, which is interacting with their students.
The intelligent support is offering that the same sort of support that I would offer if I was standing behind them. So that's a first port of call. And if that doesn't work, they've still got the opportunity to ask. But we're now filtered to people who need more than a straightforward answer, backed up with the teacher's tools which will allow me to look in retrospect at what everybody had done, not just the 2 or 3 that I saw while they were working.
I think one of the interesting things about designing technology-based systems for learning is that they give teachers insights into the learning process. We've had several teachers say to us, by interacting with the system, we, the teachers, have come to understand just how complex these ideas are, and therefore willing to put in some investment of time in order to think how best to introduce these ideas to the children using Expresar and the MiGen system.
I was impressed today by how very, very quickly and easily they were able to help the others.
Use the pink unlocked number and the blue number.
And they weren't just saying, press that, do that. They were actually using the language that a teacher would use.
If you're really going to teach maths well, it has to be personalised. And this is exactly what you can do far better with a system like the MiGen system, because by actually the students building something, that gives not only them feedback on what works and what doesn't work, but it also gives the teacher feedback in a sort of window on where that student is.